Hi, Happy New Year. This is a video where I'm going to talk a little bit about the inner workings of CPC as it regards to timers, and specifically I'm going to talk about the new update to CPC on January 5th of 2017. The majority of this, actually all of it, has to do with timers and clock times, and a bug that was identified by one of our customers recently that caused a situation where pressure became uncontrollable for a moment, and the reason that happened and what we did to fix it. So basically, a little bit about time. CPC, and here we are looking at CPC. I bring up the object editor. CPC is constantly using time, and it uses time to determine how quickly things happen, and setting intervals and setting repetitive cycles and things like that. So the recipe processor, for instance, has to keep track of time, and then it can calculate how long it's been in a run. Outputs, for instance, PID controllers also have to collect time, and the way it does that is it grabs a time or a clock value from the PC, which is basically the number of seconds since 1900, since the year 1900, and that is a lot of seconds, and you can see here at last time it says 3692865208 seconds since 1900. Okay, and that's changing constantly. So all the objects within CPC will call that PC clock function, get that value, and use it for its purposes. And usually what we're doing is we're executing something, taking the time, and then the next execution we know what the time difference is. We use that time difference, and so that's occurring all over the place. The outputs, you'll see it on timer. Each timer, for instance, tracks its own last time. And this is all coming from the PC clock. But there is a condition that occurs is, since this value is the amount of time since 1900, you can pretty much assume that if the operator changes the time on the computer, then this timer will see a big, huge time difference in terms of what it thinks the time is and what it was a second ago and now what it is. And so if someone has daylight savings time or another issue and sets a new time, what will occur is if we use that PC clock, we would end up screwing up all the timers in every object that uses timers, okay? And so we can't have that. So what CPC does is the function that gets that clock value looks at the change in time every time it's called, and it says if there's a big change in time, and it's usually greater than 60 seconds forward, if it sees a big change, it makes the assumption that was actually someone changing the clock on the PC. And what it then does is it takes that difference, what it sees as a difference, it stores that as an offset value, and then it subtracts that from the new time. So what that ends up doing is, for all the timers that are existing, they don't see a change. They don't actually see this sort of discontinuity of time, okay? And that offset is retained during the CPC session. So every time you change the clock value, that offset's going to move or it's going to change, but ultimately the whole idea is to keep all the timers at their initial settings. So we don't have these big gaps in time. This is particularly important if you're running a run and you're, let's say, 2 hours into a cure cycle, and then all of a sudden someone sets the clock back an hour. We don't want it to think that it's now only 1 hour into the cure cycle, okay? Now, what that obviously does, though, is two things. It correctly keeps all the internal timers working, but it now creates a situation where that last time becomes an errored time, because it's no longer the amount of seconds since 1900. Now it's the amount of seconds since 1900 subtracted by this offset. And the new version of CPC that we just launched exposes that offset. It's in the server object, and you're going to see something called the CPC clock offset. Okay, why am I exposing that? So that you can see whether it's it's a positive, it's 0, which it is when you boot CPC up, or a clock difference has occurred. Okay, so how does that? Let's change time on this PC just to see how that works. So I'm going to bring up my output just to visualize my actual clock value. So there's that. This is the CPC clock right now, and it has no offset because it's 0. And I'm going to bring up the change time thing for Windows. Now what I want you to look at here is this value. If I didn't have the offsetting feature and I changed time, what you would actually see is the minute that you change time, this would jump. Okay, but the offsetting should keep it consistent, meaning this should appear as if there was no time change. So I'm going to take this time 11:57 and I'm going to make it 11:47. Okay, so I'm going to subtract 10 minutes. So here you have 472, 474. The minute I change this, boom, you'll see it said 478, 479. So nothing changed, even though I moved the PC clock. Now what did change though is CPC in the server object. You'll see that now there's a 609 second offset. Okay, because what I did is I moved the clock back 10 minutes, which is 600 seconds, and CPC said, oh, wait a minute, I can't have that, so I'm going to add 609 seconds. So that offset is there. It's going to be retained there for the rest of the CPC session. Now, if I close CPC, bring it back up, it's going to load back in a 0, okay, which is usually okay. Where it's not okay, though, is if I happen to be in a run which is using this offset, and then I reload the CPC. Let's say PCA, I close CPC and reload it during a run. It's now going to reload back with a 0 offset, and now that creates a problem because now the recipe says, hey, wait a minute, I'm an hour before or an hour after, and that's what happened at Albany in Utah. They had a situation obviously where someone had changed the clock value during a CPC session, and then they started some runs and ended some runs. But at some point, they had a situation where PCA was no longer controlling, or it reloaded, or it moved to PCB. Well, either direction, what occurred was the time was no longer accurate, and it was off by a lot, and it created problems with the PID controllers, and it created problems with the data. Okay, so what this new version does is it corrects all that, and let me explain how we're going to correct that. So the whole idea is that the normal reboot of CPC, where the offset gets set back to 0, is correct, except for the situation where you are in a run. Okay, so it's important then to basically tell CPC, hey, when you're booting up, and if I happen to have been in a run, then retain this clock offset. Don't zero it out. Okay, and to do that, now we have a method called retain previous clock. Okay, now that's a method, and where we want to put that, and all of your configurations are going to have to start doing this, is in the on startup script. Okay, and the recommendation and actually requirement now is that you put these 3 lines in the startup script, and basically it says if autoclave recipe processor / run status, and this could be oven, or it could be other things, run status equals on, meaning I was in a run when I boot up, then me retain previous clock. Okay, so that method will then retain that original value, which is now stored in the objects file, right, from the previous, from when the thing went down, and it will then keep a continuous cycle. Timers will all be contiguous. Okay, and obviously if I wasn't in a run, it's okay to zero it out. So basically that is an important thing that you need to do. It's going to avoid a lot of problems in the future in terms of possibly having problems with data being reverted differently, and trending, and also PID loop problems. Okay, so that's the first thing. Okay. Now the next thing. So the next problem that in researching this and analyzing this, I recognize that on the trend screen. So here I've got a 5-second trend. I'm going to start a trend, and the reason I want to show you this is I want to let you see how trending works. Okay, so trending is collecting not only that timer value for each data point, but also the actual date and time. And so here you'll see that I'm able to when I click on a trended point at the very top up here, it's displaying the time of day, and at the bottom how much time in the trend. Okay, so down here it's 0.5, and here it says 11:52. Now what the previous version of this software did is, even though there was an offset in there, when I changed my time, it would actually still show it would show a time and date that's actually wrong in the trend. It would not reflect that change of time, which was erroneous to the operator, because they might think that it's 11:52, but on the trend it will actually show it would show 12:02, because it's going to reflect the time and date with the offset in there, right? And so that has been fixed. So now here, for instance, if I change the time while I'm trending, okay, so here I'm going to go down, change the time. I'm going to change it 10 minutes ahead. So here I am. Let's change time setting. Okay, so before, basically, if I change the time, what would occur is it would not reflect that time change. Okay, now if I change the time, so here's 11:58. I'm gonna now, it's 12:04, so I'm gonna say 12:04, and I'm gonna press OK. Okay, and look what happened there. Even though this is on a time scale, I changed my date and time by almost 10 minutes, right? And now the trend doesn't jump 10 minutes ahead, doesn't 10 minutes back. But what you do see is, as I move here, you will see that it actually changes the date at the top, okay, and the time, or the time at the top. It says 11:53, 11:53, and then immediately 04. Okay, indicating that we jumped to 12 o'clock. Okay, actually I'm in the wrong thing. 12 a.m. It's actually 12 p.m. But let me change that. Let me change that time here properly. 12:04 p.m. Okay. Okay, so I then now changed it 12. So I just changed it 12 hours, and here we are showing the correct 12:05. Okay, so basically, what this tells us is that, or what the correction was on the trend screen is it isn't going to give you the wrong date at the top, but it is going to sort of not give you big discontinuity on the trend screen. Okay, so those are the two major issues which have been corrected. The other thing, now, if we pull up our document, you're going to see, so server object, change the clock timing function in order to allow retention of clock adder. That's that clock adder, or clock offset. Added a property, CPC clock offset, to hold the current offset. Added a new method, retain previous clock, which is now to be used on startup. I also changed what would create a clock offset. So it isn't the case that it's going to create a clock offset every time the time is slightly different. It's going to wait for a change of 60 seconds or more positive, or any change that's negative. So that's been changed. And basically the other thing which is really nice now is it's obviously very important for in a PCA PCB system, so that both PCs always have the same time. And what we had to do in the past is an operator has to make sure that both PCs are always have the same clock value. Well, now CPC will actually do that automatically. And the way I'm going to demonstrate this is I've got my desktop computer over here, and I'm going to connect to that. So I'm going to say connect to, and this one's dMason Win 7. That's my desktop computer. We'll wait 2 seconds. It should connect. And I'll make a, is it going to connect? Let's make sure it does. Well, oh, there it goes. Did it connect? Yeah, okay, so there it is. Took a little bit of time, I'm not sure why, but okay, so now we're at the very bottom. You see asset 1316, which is my laptop, connected to dMason Win 7. So now what you see is that now that I'm connected to that server, that's 1208 right now, okay? So if I turn to my desktop computer, and I'm going to change my time on my desktop computer to, let's say 1218, okay? Now right away you see there's a date time synchronization, and this actually shows you that that the local machine now, okay, which is the client machine, which is what I'm on right here, changed its own time. And if I go to Windows, you'll see that now says 1218. So CPC in this case, actually the client that was running on my laptop was connected to the server on my desktop. The server time was changed, therefore the client on the laptop changed its own computer time to match, okay? So if this were the PCB computer connected to PCA, and PCA's time is different than PCB, then the client on PCB knows that it's going to issue a time change. So this is a client function, a new one now. So basically what that means is any change, any discontinuity between clocks on any PC connected to the server will synchronize them all, okay? And those are all the changes. Why is it important to us? It's important so that we don't have a situation that Albany had, where basically a big discontinuity occurred. And so this has been a long-standing, I guess, issue in CPC. Fortunately, clocks don't get changed much, and when they are changed, they're usually changed when CPC isn't running. This problem that occurred only happened when someone changes the clock while CPC is running, and now that's been corrected. Okay, so the only thing you have to do is download the new version, start using that, but also on your on startup script, begin to put in that retain the retain previous clock. Okay, thanks and good luck.